All right, how's it going? My name is Brandon Fairchild, and I will be showing you how to make a funnel, a model of funnel in Fluent. So here we go. I've got my two projects here, but I'm just going to do another one as an example. I would show how to do these ones, but I am limited on space on my computer, and I can't record a full video showing the entire process here, so I'm just going to try and do a quick summary here. So first we're going to start with the geometry. We're going to right click and open new design modeler. And we'll just wait for this to open. Let's just make sure. Okay. So we got it loaded up. We're going to go to XY plane and go to sketching, get some lines here. And again, I'm just going to be doing a quick summary of how I did this. So I'm not going to get all the lengths exact, but I could explain how to do that. Let me get out of this. So from the origin, and draw two vertical lines outwards. And we're just starting with the test section of the funnel here, or the wind tunnel. So two horizontal lines, we'll go over to dimensions. And again, this is just an example, so I'm just going to use rough lengths. Maybe let's say 5. Let's go 1 here, 1 here. Oh, that should be 5. And 1 here. So we should start getting the resemblance of a rectangle here, as you can see. You can go back to draw. I'm actually going to get rid of these dimensions. All right. I'm going to do a few steps here. All right, so we're making the contraction cone here. So that's going to be part of the cone, and we're just going to make a horizontal line underneath it, and that's just going to be able for us to be able to determine the angle of this cone. And we're going to do the same thing on the side here for the diffuser. All right. And again, this part doesn't have to be exact. We're going to go into the dimensions and fix that all up. So we'll get a dimension here, and we'll also go to angle, and we want to get, this is the angle we're trying to determine here. There we go. The angle between these two. And the angle between these two. All right, so then we'll go back into the dimensions and make sure these are all equal, so L5 and L6. Let's say we want each of those to be 4 meters. Length 7 and length 8. Let's say 5 meters for those. And then for A9, A10, we want those to be the same. So for A9, and we have the outer angle here, so I'm just going to do 360 minus whatever that is, and I'm just going to go with the 30 degree angle here for both of these ones for A9 and A10. This one we'll just put 30. So these now are at the same angle. And for this side, we want A11 and A12 to be the same. So for A11, let's go 20 degrees on these. So I'm just going to put in 340 for each of these. Then we could go back and just delete all the dimensions since we got those set. Come on. There we go. And we can also delete these horizontal lines because those were just used as reference. These were also used as reference, these verticals on the axis. And then finally, we could draw a vertical line down here. And this is also an indicator that everything was done right, is that it shows the vertical symbol on it, which you could have seen right there, and you'll see it on this side again. Because if these are the same length at the same angle, this should be vertical. All right, from here, we're going to go back to modeling, or we're going to hit concept, surfaces from sketches, and we were working the XY plane on sketch number 1, so it's going to now highlight all of this. We're going to apply it to that and generate, and this is what it's going to look like. And if we wanted to model with an object in the test section here, we would just go back to sketching before we did this step and draw in a circle, triangle, whatever object we wanted to test the flow around. But for this test case, I'm not going to do that just because it's going to slow down when I try to calculate all the iterations. All right, so we're going to go back to Workbench. We have the geometry done, so we're going to open the mesh now. So we'll wait for that to open up. I apologize for the loading times here. All right, should load up here in 1 sec. There we go. I'm just going to get it on the right axis to see it better. We're going to go to Mesh, right click and insert a method there. Click on the surface we're doing it to, go to Geometry and click Apply. So now you should see it's all highlighted here. Hit Generate. And so now it's going to generate. Oh, actually, I want to do that with triangles here. So we'll just switch that to triangles for the method and hit Generate again. All right. We could go back to Mesh, and we could look at the statistics to see the amount of nodes and elements we have. And this is a little too low for me. I would like it to be a little more accurate. So in order to do that, we're going to go up to the element size and maybe switch this down to 0.01 meters. And then we're going to click Generate. And it's going to take a minute here. I might have made this element size too small, just because that's why it's taking forever to mesh. Depending on the restrictions of your computer, you might want to lower this to not be as fine, just so your computer is able to process it, but we should be able to see this mesh out in the next minute here. Okay, so just for time purposes, I'm going to switch to one of the ones I've already done since this isn't meshing. So let's go to one of my ones I did. So this was one with the object, but let's go to the other one because this is the one without the object. So we could go through and we could see, if we go to mesh, we could look at the statistics and we could see here I have 33,000 nodes with 66,000 elements. And if we zoom in, we could see how fine that does get. Just click on here. There we go. So we can see it gets pretty fine. And in the cases where, let me just double check if this has gone yet. Nope. So in the case with the object, what I did is I also added, I went to mesh, insert, and inflation. And what that does is it's gonna, as you can see here, it applies, is that not gonna load? It's basically around the boundary, it will calculate more specifically, so we could more clearly see what's happening around the boundaries without having to make all of or the rest of the mesh super fine. And it looks like this may have just loaded. No, I don't know why that's not working. Anyway, we'll just go off this one as an example. So then we go and name all the sections. So in order to do that, we go to the edge tool up here, click on the edges. So this front edge I would click on, and as a shortcut you could click N on the keyboard and it will just pull up the selection name, and then you could type in. So this front wall, I already named it, but we have the velocity inlet, the pressure outlet, the wind tunnel walls. So I kind of just grouped all of those together. So it's this top set of walls and bottom set of walls, and the wall model, because we're going to have a boundary around that object that we're modeling the fluid flow around. Uh, after we do that, just double check this is still meshing. So again, this is an example of why you should not do what I do, or not do what I did and slowly decrease your element size, because my computer can't handle this right now. So after this step, I just named all of them, created the mesh, and then we would go back to Workbench. And from there, we would go to Mesh, right-click that, and then hit Update. I'm not going to do that, but that will just update the mesh. And then we would go to Setup. And that's where we could define all of our values. So let me go to that and show you guys what that looks like. I wish this was working so I could show you from scratch, but from here, it's going to start with this page, the general. Looks like my license stopped working, so the whole program stopped working. Don't want to close Fluent. It looks like we might have to. It looks like this crashed it. So I'm going to stop this recording and I'll pick it up and pick up where I left off.